They came not to conquer the Himalaya, but to read its secrets, written in stone and ice, where no map was certain and the earth itself was still in motion.
It's 2:20 a.m. I'm still buried in the Himalayan Club journals, century-old field notes from the Himalayas. It's like diving deep into the documented history of the Himalayas from the early 1900s. The journals cover everything, from indigenous wisdom, cultural myths, to epic expeditions and groundbreaking discoveries. These forgotten stories are brought to life by synthetic voices in the Himalayan Journals podcast. Subscribe, zone out, binge, and pass it to a fellow mountain junkie.
In 1936, a Swiss expedition set out for the central Himalaya. Unlike most Himalayan ventures of the time, their goal was not to climb for glory, but to study the geology of the great mountains. The leader, Arnold Heim, had spent nearly 20 years examining the Alps and now wished to compare their structure with that of the Himalaya. Geologists in India had already uncovered thrust sheets in the border ranges, but the central part of the great Himalaya remained almost unknown. Earlier surveys had touched the Tibetan border, and von Kraft had even suggested that curious limestone blocks in Mala Johar were products of vast volcanic outbursts. Yet no one had challenged his view, nor had the area been revisited for decades. The Swiss expedition was small. At the start, it consisted of 3 men, but soon was reduced to 2 when W. Weckert, a well-known alpinist, was carried back to Raniket for an operation. Support came from the Swiss Academy of Sciences, and the party relied on local food rather than heavy supplies, a method they felt more efficient. Heim was joined by Dr. August Gansser, a young geologist of remarkable ability, and also a member of the Himalayan Club. Their journey began swiftly. In 3 days, they flew from Rome to Jodhpur, passing over the Persian Gulf and the Strait of Hormuz, where young anticlines and salt diepirs stood exposed in the desert. From Jodhpur, they traveled on to Delhi, Calcutta, and then Darjeeling, where they studied the gneiss and its position above the Darling series. In the foothills east of Darjeeling, their work confirmed that the so-called Great Boundary Fault was in fact a relief thrust, and that the Siwaliks were not overturned, but had been eroded before being covered by Himalayan thrust masses. An invitation from J.B. Auden of the Geological Survey of India led them to Mussoorie for a week, where they gained further knowledge of the border formations. The main task then began: a 6-month cross-sectional study in Kumaon. Starting from Almora, they followed the Kali River near the Nepal border. Garbyang, a village at 10,320 feet, became their first base. From there, they made excursions to the Tibetan frontier, even crossing into a corner of northwest Nepal. Gansser discovered glaciers thrust upon one another in a way similar to the Karakoram, and with folding skis, the pair climbed 2 previously unknown peaks of 19,000 and 20,000 feet. Fossils were collected at 17,000 feet, including ammonites from Triassic horizons not seen before. At Kuthi, the highest village in Kumaon, they made a second base. There, they identified overthrust masses piled upon each other, requiring corrections to earlier surveys. Plans to climb Shangtang were cut short by the monsoon in June. Gansser took a bold step, joining sheep drivers into Tibet, and returned 12 days later with valuable discoveries. Despite the storms, they crossed high passes such as the Shiala, Lebong, and Ralam, hearing the thunder of avalanches. At Milam, they turned to the exotic region of the Kyogars. Their work showed that these exotic rocks were not scattered blocks from eruptions, but vast thrust sheets covering large areas, similar to the Klippen of the Alps. Later, they returned by the Kungri Bingri and Antadura passes. Yet orders from the authorities forced them back to Almora, for Gansser had entered Tibetan territory without permission. On the way, under heavy snow, he crossed Trails Pass between Nanda Devi and Nanda Kot. Forbidden to go beyond the inner line, they shifted their plans to Garhwal. In September and October, with weather clearing, they moved to Badranath. At the Bhagat Karak Glacier, they camped for 3 days at 17,000 feet. Gansser climbed a sharp, unnamed peak of about 20,000 feet and brought back a panorama of the surrounding mountains. Geological study revealed intrusive rocks, including a striking white tourmaline granite. They also visited the Satapanth Glacier before returning to Almora. From Binsar, they photographed one of the finest panoramas of the Himalaya, with Nanda Devi standing in the center. Their studies traced terminal moraines of the Pleistocene glacial period down to 6,560 feet, showing how much farther the ice had once stretched compared to the present snouts at over 12,000 feet. The glaciers of today, they observed, seemed to be retreating, heavy with debris, conserving rather than eroding. Rivers, on the other hand, cut deeper gorges and carried away deposits, evidence of the Himalaya still rising. The work was not finished. Rocks, fossils, and samples awaited analysis and study. A book of maps, photographs, and sections was planned. Heim concluded that the Himalaya was the product of a vast movement of the Earth's crust, flowing from Central Asia toward the plains of India, and that this movement was still alive. He also reflected on the timing of expeditions. Too often climbers had been caught by the early monsoon. Perhaps, he suggested, the clearer skies of late September and October offered the best chance for both science and climbing, despite the cold. For the Swiss scientists, the journey had shown not only the structure of the Himalaya, but also the kindness of the Geological Survey of India and the people of the mountains. Their modest expedition had left behind a clearer picture of the Great Range, both as a landform and as a living geological force.